Hello, welcome back to our factory label method part 3. We're taking a look at combination units and density in multi-step problems today. Alright, so our first example here, we're working with some combination units. And what I mean by combination units is you see we have a unit decimeters cubed per second. So there's our combination unit there. The unit on top, unit on volume. The unit of volume, decimeters cubed, and a unit of time on bottom, so volume per second. And we're trying to take that to liters per minute. So we're in a combination unit. I mentioned to you the other day that whenever possible, we want to start with the unit that only has one value. Unfortunately, it's not an option here. They both have multiple values, so we're just going to have to start with a number on top, or a unit on top, and a unit on bottom. But that's okay. We'll get through this. So we're looking for liters per minute. So question mark liters over minute. Again, notice no slash. We do not want the slash. It is very difficult to work with mathematically. Instead, we just put liters over minutes. And that's going to be equal to, we were given 822 decimeters cubed per second. Again, no slashes. We've got the decimeters cubed on top, seconds on bottom. This is a volume. This is a volume, so I match those up. This is a time. This is a time, so I match those up. All right, now you could go seconds to minutes first. I elected to go from volume first. 1 decimeter cubed is 1 liter. That's a conversion hopefully you guys are getting very comfortable with. You've probably seen it a few times so far in your homework. So 1 decimeter cubed is 1 liter. It's a pretty easy conversion. Now decimeters cubed is gone. We have liters on top. That's what we want. Excellent. Now we just got to get minutes on the bottom. Hopefully another conversion we're all very aware of. 60 seconds and 1 minute. Notice the 60 seconds goes on top. I need to cancel out the seconds. It's on bottom here, so you need to make it on top here. There we go, 60 seconds in 1 minute. Now I'm left with liters per minute. That's what I want. Simple calculation in my calculator, 822 times 60. I've only really got one number here, 3 digits. So 3 digits in my answer. These are both exact conversions, so we aren't going to limit ourselves to those digits. All right, well, let's take a look at another one here. 0.78 liters per minute to cubic centimeters per second. So you're going to move from a volume on top, liters, to a volume on top, cubic centimeters, and from a time on bottom, minutes, to a time on bottom, seconds. You can set that up without those slashes. Slash just means a line, one unit over the other. Again, you could go minutes to seconds first. I like to go from liters to milliliters. And then milliliters to cubic centimeters. Again, this is hopefully one of those conversions that you have memorized. 1 milliliter is 1 cubic centimeter, so 1-to-1 ratio. So there we go. Pretty easy. We've got our cubic centimeters on top. That's what we wanted. Now let's convert minutes to seconds. Again, hopefully conversion we're all fairly well aware of. Minutes goes on top, so it cancels out the minutes on bottom. 0.78 has 2 significant digits. There's infinity here, and infinity here. All 3 of these are exact conversions. So we'll be limited to just the 2 significant digits, 13 cubic centimeters per second. And again, if you want to write it like I did up here, liters per minute with the bar under it, that's fine. If you want to go back to the slash, that's fine. Either way is perfectly all right for writing. Okay, convert 0.95 kilograms to cubic centimeters. Convert 0.95 kilograms per cubic centimeter to milligrams per cubic millimeter. All right, so this is where I'd highly advise that instead of writing millimeters cubed or centimeters cubed, just go ahead and write centimeters times centimeters times centimeters. It's the same thing. Centimeters times centimeters times centimeters is centimeters cubed. I think it makes it easier to see it, the conversions that we need to make. So first step, I'm going to go kilograms to grams. You might be comfortable going from kilograms to milligrams in just one step, but I like to go back to the base. The base is grams, so I'm going to go back to the base. Now that I have the base, now I'll go out to milligrams. So grams to milligrams. Cool, and I'm good on top. I've got my mass converted. Now I've got the volume to go through. All right, so here again, this is why I like to list out centimeters times centimeters times centimeters. There's 1 centimeter gone. I've still got 2 more to do. Here's the second one gone. Still got 1 more to do. Here's the third one. Okay, there we go. There's our cubic centimeters. I had to do it 3 times because there are 3 of them. That's the idea of the cubed unit. Now, unfortunately, I've got meters on the bottom, cubic meters on the bottom, and I need cubic millimeters. I still have 1 more conversion to go. And again, it's a good thing I've got them listed out. So I can see, there's 1 of my 3 meters. There's the second of my 3 meters. And there's the third of my 3 meters. So, voila, cubic millimeters down bottom, millimeters times millimeters times millimeters. We've canceled all our other units out. We've got milligrams on top. And we end up with 950 milligrams per cubic millimeter. Okay, double check our significant digits. We started with 2. All of these, every conversion we used has unlimited significant digits, infinity significant digits, so we'll be limited to the 2 that we started with. So 950 milligrams per cubic millimeter. Okay, so those were the combination units. Now let's take a look at using density as a conversion step. So what if you have multiple steps to do? And a density is one of conversions. So that's the next set of examples we'll work through here. Determine the number of grams. All right, so we're looking for question mark grams present in 7.62 cubic centimeters of a material with a density of 2.5 grams per milliliter. All right, so we've got 2 units here. Again, I highly recommend whenever this is the case, choose the unit, or choose the number that only has 1 unit. This one only has cubic centimeters, that's 1 unit. Over here, we've got 2 units. Again, choose the one that has 1 unit to start with, 7.62 cubic centimeters. Very cool. I need cubic centimeters on the bottom. I'm going to put milliliters on top. That's a pretty easy conversion, 1 to 1. Hopefully we have that memorized. Why did I go to milliliters? Well, because I look over at my density, I've got 2.50 grams per milliliter. I need milliliters on the bottom. There's my density. Milliliters converts to grams, and voila, I was looking for grams. So there we go. My volume has canceled out, and I've used the density to go from volume to mass. 3 significant digits, 7.62, 3 significant digits, 2.50. Yes, a density is a measured value, so there's not infinite there. That's just 3 digits. I get 19.05 when I plugged it in the calculator. I only can have 3 digits though, so that 5 tells me to round the 0 up, 19.1 grams. Okay, convert 1.25 grams per decimeter cubed to milligrams per centimeter cubed. Okay, there we got our cubic units again. Cubic units, again, best way to list them out, all 3 of them there. I went ahead and went from grams to milligrams first. You don't have to, you can do that at the end if you prefer, or even in the middle if you really want to. But I got it out of the way first, and I've got my milligrams on top, Now I need to get out of decimeters on the bottom. I want centimeters, I have decimeters. So a decimeter, there's 1 of them. There's the second one. There's the third one. Okay, all 3 of my decimeters are gone. Again, I converted back to the base, which is meters. But what I really want are centimeters. So I've got another set of conversions to go. Now I need to go from meters to centimeters. And again, I need to do that 3 times. I've got 3 meters here to cancel out. And at the end of the day, I want 3 centimeters. So there's my 3 centimeters. And my 3 meters cancels out. Again, at this point now, all my units are canceled out. I've got milligrams on top. That's what I wanted. I've got cubic centimeters on bottom, or centimeters times centimeters times centimeters. That's what I wanted. So I'm good to crunch my numbers on my calculator. 3 significant digits, and oh my, look at that. All that work, and the number didn't even change. So very interesting. You'll have that from time to time. but definitely still worth doing all the math to make sure. It doesn't happen very often. 1.25 milligrams per cubic centimeter. All right, that was definitely the worst one on this page. The rest are not nearly as bad. We don't have any more cubic units to work with, at least not lining them up like we did up here. So, next question, if a substance has a density of 1.25 grams per cubic centimeter, how many grams will be present in 233 liters of the material? All right, so how many grams, question mark grams, is equal to, again, I've got a double unit, grams per cubic centimeter, and I've got liters. Push comes to shove, I want to choose the number that only has one unit. In this case, 233 liters. There's my 1 unit. First step here, I'm going to convert liters to milliliters. And next, I'm going to go milliliters to cubic centimeters. Why do I want cubic centimeters? Again, I'm looking up here. My density has cubic centimeters. So in the next step, we know we'll be able to use that. There it is. Cubic centimeters goes on the bottom. The 1.25 grams goes on top. And now we've successfully converted from a volume to a mass. How do we do that? We use the density. Volume to a mass. There we go. Only 3 significant digits. 3 in 233 liters, that's a measurement. And 3 in our density, 1.25. So our final answer has just 3 significant digits. And the last problem, kind of the opposite of the one we just worked. Same density, 1.25 grams per cubic centimeters. This time they're asking for a volume, how many liters, and they're giving us a mass, 233 kilograms of the material. So what's our liters? If we have 233 kilograms. First step, I'm going to go kilograms to grams. Next up, there's my density. Again, notice I need grams on the bottom so that it cancels out. There they go, they canceled out. That means the 1.25 goes on the bottom. Keep that 1.25 with its unit. It's 1.25 grams. So 1.25 grams. Here's my cubic centimeters. On top this time, now it can go on bottom, so I can cancel out with milliliters. And finally, milliliters on bottom, converted to liters. That's what I wanted. That's what we have. We're left with liters. We crunch the numbers. Calculator spits out 186.4, but I only want 3 significant digits. So only 3 186 liters.